Influence of a contact parameters in fatigue contact 3D problems. In this work, we will use the stretching finite element method, which is a new method to study the influence of a contact parameters in fatigue behavior. For that, several parameters are made to vary, such as geometric shape of the mesh, materials, contact parameters. The stress intensity factors are calculated by varying the above parameters. A numerical simulation of parametric mesh in 3-dimensional is composed of specimen which is subject to the tense stress and the pad which is subject to the perpendicular pressure. Note that the two bodies are in full contact. A Fortran code is used to create the mesh, while the Abacus computer code is used to determine the stress intensity factors. For each case study, the friction coefficient parameters, the size mesh, the inclination of the plane, the size of the singularity zone, and the stress are varied to obtain the value stress intensity factor for each material, steel, aluminum, and brass. Through the result obtained, the first mod shows the higher value for the 3 material test and for all the different parameters. The size mesh, the inclination of the plane of the crack, and the coefficient of friction have an inverse effect in the evolution of a mode K1. Aluminum is more influential in the evolution of K1 mode. We conclude that the parameters which have been applied externally have an efficiency compared to the parameters which have been applied internally. Finally, with this SFEM method, we can study a large field of parameters and compare several results at the same time, which allow us to make a rather rich study.